Now let us understand the structure of glucose, which is also called aldosis or dextrose. See, a lot of series of reactions are done in order to conclude that, okay, fine, this particular biomolecule is having this type of a structure, and the process is called structure elucidation. The same is done here with the glucose molecule in order to confirm its structure. First, its molecular formula was found to be C6H12O6. Then, the glucose is reacted with HI, which gives N-hexane. Now, it's a reaction with HI because it's a very strong reducing agent. It reduces all aldehydes, ketones and acids groups and alcohols to the corresponding alkanes. Confirms that the glucose contains a chain of 6 carbons, so it contains a straight chain of 6 carbons is a proof which we get from this reaction. Then the glucose is reacted with hydroxylamine, which gives what? Oxime. It is reacted with HCN, which gives cyanohydrin. Now the formation of oxime and cyanohydrin both confirms that it contains a carbonyl group, a pure carbonyl group. So it will be either aldehyde or a ketone, because these two are characteristic reactions of the carbonyl group. Then the same glucose molecule is reacted with bromine water, which converts it into a monobasic acid, gluconic acid. We know always bromine water only converts an aldehyde into an acid. So it was concluded from the formation of the gluconic acid that it contains what? Aldehyde, not a keto group, because ketone cannot be oxidized by bromine water. Since the aldehyde contains one acid, the CH bond is there, which can be oxidized. So gluconic acid formation indicates that the functional group present or the carbonyl group is present in the form of an aldehyde group. When the glucose molecule is acetylated using acetic anhydride, what happens is the esters are formed and 5 molecules of acetic anhydride in that respect were used. So 5 esters, 5 acetyl groups were found to be attached to the one glucose molecule, which indicates that it contains 5 OH group. So this on acetylation with either acetyl chloride or with acetic anhydride, which consumes 5 molecules of acetic acid or acetyl group per glucose molecule, indicates there are 5 OH groups, because 5 esters are formed on this one single molecular chain. Then on oxidation with nitric acid, the same glucose form what leads to the oxidation of its aldehyde group as well as its primary alcohol. So what happens is, even the same compound is also obtained on oxidation by nitric acid of gluconic acid. Now this oxidation by nitric acid of the glucose giving you this COH, CHOH, 4 and COH, which is called adipic, sort of an adipic acid, but it is not an adipic acid because it contains 4 OH group. I'm saying because there are 6 carbon chain, one COH at one end and COH on the other end. This reaction shows that the glucose molecule contains, out of the 5, 1 alcohol as a primary alcohol, and that is which has been actually oxidized by using gluconic acid also, and rest of the 4 OH groups are secondary. So this is how we came to the conclusion of an open chain structure of the glucose molecule, whose exact spatial arrangement is obtained by doing number of or series of reactions, and in the end we can draw its spatial structure to be like this. It's like this. It's like this. So it's carbon number 1, 2, 3, 4, 5 and 6. And remember, all OH groups of the glucose molecules are on the right hand side except the third one, which is on the left hand side. And this is what is here is complete glucose molecule, which can be put either plus or minus, because plus means dextrorotatory or minus means levorotatory, that we cannot judge, that can only be determined experimentally. And before this we put either D or we put L. Now what does this D and L means? These are relative configurations which are with respect to what? Glyceraldehyde molecule. What we do in this relative configuration is, if the second last carbon is having its OH group on the right hand side, this one, it's called D form. If the OH group is on the right hand side, it's called D form, and if it is on the left hand side, it is called L form. So this is what we have is the D form. We know that these are your relative configuration, which are mainly used for carbohydrates and amino acids. In amino acids, we see the NH2 group. In this case, we see the OH group of the second last carbon atom. If it is on the right hand side, it's called D form. If on the left side, it's called L form. So this is called D plus glucose, because it is actually having an OH group on the fifth carbon on the right hand side. So this is the exact spatial structure of your simple glucose molecule.